The broadcast is now starting. All attendees are in listen-only mode.
Hi, and welcome to today's SFP webinar on sprinkler protection of storage, updates and research from NFPA. This is Louis Garazzi, SFP's Manager of Professional Development, and I will be moderating today's webinar. Before we get started, I'm going to go over some information in regards to the webinar logistics. First, all participants will receive a certificate of attendance for 1 PDH. To receive a certificate, you must stay online for the entire webinar, and certificates will be sent out via email within 1 week. Also, we do not provide copies of the speaker's PowerPoint presentations. However, we will be posting a video of this presentation on SFPE's YouTube channel and website within the next week. Additionally, you can ask our speaker questions by writing it into the webinar dashboard. You may ask a question at any time. However, we will not be taking any questions until the end of the webinar. Today's speaker is David Haig. David Haig is staff liaison for NFPA Sprinkler Project, including NFPA 13, 13D, 13R, NFPA 24, NFPA 291, and Foam Project, including NFPA 11 and NFPA 16. Dave began his career designing fire protection systems, including sprinkler, standpipe, water spray, fire pump, and foam systems for the Automatic Sprinkler Corporation of America. He has a total of 17 years in contracting and has spent 16 years with NFPA and 7 years in the insurance business as manager of engineering technical unit of Liberty Mutual Property. He has served as technical editor and contributing author of several books, including Fire Protection Systems for Special Hazards, NFPA 13, NFPA 20, and NFPA 25 handbooks, the Fire Protection Handbook, and the Handbook on Commissioning of Fire Protection Systems. Dave is a registered professional engineer in the state of Massachusetts, a certified fire protection specialist, and is NICET certified in sprinkler and special hazard systems. So, with that being said, welcome, Dave.
Thank you, Lou, and good morning, everyone. Thanks for joining us for this seminar. And I'd like to begin by advancing into NFPA 13. Finally, proud to announce the issue of the 2019 edition of NFPA 13, which was a massive project. And some of you may already know this, but we undertook a major reorganization of the standard. I hope you like the new layout. I wish I could spend more time to talk about the standard overall, but our focus today will be on storage. So putting NFPA 13 to work and focusing on storage will be our focus. And one of the more significant changes to NFPA 13 was, in fact, the storage chapters and the way we approach storage. So just very briefly, you can see the chapters on your screen. Chapter 20 was the previous chapter 12 and so on. But the approach that we take to analyzing storage has changed dramatically as well. The 2016 edition of NFPA 13 focused on how we stored materials, and we had chapters on rack storage and so on. But now we focus on the protection scheme for storage. How are we going to protect that? Throughout the process of revising NFPA 13, I wasn't the biggest fan of this. I'll be perfectly honest with you, but the more I look at it, I'm starting to accept it. So it is a drastic change in how we view storage. So as you can see, Chapter 20 deals with general requirements, but then chapters 21 through 23 deal with how we protect storage. So we're starting with control mode sprinklers, then special application sprinklers, and finally ESFR sprinkler requirements. So we're looking at it from the standpoint of how we protect storage. And we can't forget rack storage. That's in chapter 25. So everything dealing with rack storage has been put into one chapter. We kept that intact in chapter 25. So when we analyze storage now, and this may make your job a little more difficult, because as an engineer, you're probably going to look at storage of, you don't start by thinking about how you're going to protect it necessarily. You start by thinking, and we'll talk more about this in a few minutes, but you start looking at first, well, what's the commodity? How is it stored? How high is it stored? And then based on all of that analysis, you finally make a decision as to what makes the most sense for a protection scheme. What is the most economical protection method? So you might ask, why did the committee do this? Well, the thought process was the end user, the plan reviewer, the casual user of the standard. Let's design this, let's organize this to help them. So if you can imagine a casual user of the standard, don't use it every day, but I do have the responsibility for reviewing plans, and I get a set of plans dropped on my desk. Where do I begin? Well, if I know that those plans include ESFR sprinklers in a warehouse, I can go right to Chapter 23 to find the information that I need to properly review that plan. So that was the thought process in redesigning the standard in this fashion. Now, to help you navigate your way through the standard, as I mentioned before, we moved just about every section of the standard. We didn't move chapters as a whole, so the whole thing changed, and it was quite an undertaking. So what we decided to do was provide what I call a roadmap in the back of the standard that shows all of the sections from the 2016 edition and where they were moved to in the 2019 edition. So on your screen, what you're looking at is basically a small snapshot of the previous Chapter 12, and you can see that most of that moved into Chapter 20. That was a pretty easy chapter to deal with, but trust me, a lot of chapters were broken into smaller pieces and moved to a multitude of different chapters. But for our purposes today, we'll just deal with the storage chapters. And also the roadmap will show you where certain sections were deleted. Now, overall, we deleted almost 500 individual sections from the 2016 edition, primarily because they were redundant and not useful. So we did trim down the standard considerably. So when you go to use the 2019 edition of NFPA 13, I highly recommend you go to the back of the book, search out the section that you're probably very familiar with in the 2016 edition, find out where it was moved to in the 2019, and start using the book that way. And as you become more familiar with the 2019 edition, I promise you, you're going to like it. It's a logical organization. So with that, I think we're ready for the first polling question. I'd really like to know how you feel about this organization and whether you think the roadmap will be beneficial when you start using this new standard. Okay, so we'll keep this open for just a few seconds. And please tell us what you think about the use of the roadmap. And I'm going to close the polling starting right about now. Okay, so thank you for that. And we'll take a look at those results.
Dave Lewis here. Can you see the results of the poll here? I'm not sure if as presenter you'll see them, but if you can't, if you can't, we have 95% coming in as yes, it will be helpful, with 5% being no.
Okay, good. Those are good numbers, and thank you for that. It's good to know that will be helpful. So. There we go. Okay, so let's start with Chapter 20. Now that, as you saw in
sorry, Dave. Your screen did not go back to showing. So if you just share your screen again. There we go. Thanks.
There we go. Okay. Okay. Let's start with Chapter 20, and as you saw in the roadmap, this is where most of Chapter 12 was moved to. So this chapter will start with the general requirements for storage. And as I mentioned before, when we start analyzing storage, we tend to look at these four critical factors. First of all, the most important is what is being stored. What kind of commodity is in this warehouse? And is it combustible? Does it burn? Does it not burn? So we start making those decisions. And we'll talk more about commodity class in a few moments. Then how is it being stored? Is this being packaged in a certain way? Is it in racks? Is it in solid piles? Is it palletized? So we look at that because the protection criteria can differ substantially based upon how the commodity is being stored. And then the big question is, how high is it being stored? We're going higher and higher with warehouses all the time. And we are limited with the data we have for protection criteria on storage height. So how high is it being stored? And then finally, how high is the building that is housing that storage? That's pertinent as well, because what is the separation between the top of the storage and the roof or ceiling in that warehouse? So those four basic questions need to be answered before we start making any decisions as far as design and protection criteria. So again, the storage arrangements, and each chapter will deal with these individually. Is it palletized or is it solid piled, which is a little bit better protection-wise because it's more difficult for fire to penetrate that pile. Bin box presents specialized storage problems because it creates obstructions to discharge. Then shelving, is there solid shelf in the rack? That creates another obstruction issue and may require protection at above each shelf. And then finally, rack storage. We know the deal with rack storage, flue spaces, whether they're longitudinal, transverse flues, do we have to place sprinklers inside the rack? So we still have those decisions to make. Very briefly, and for some of you this could be review, but for others it may be relatively new. The commodity classes are identified in NFPA 13, starting with commodity class 1 through 4. We'll give you examples of those in just a moment. Those are pretty easy to work with. And then plastics, which really seem to give us some challenges. Group A plastics in particular burn with a great deal of heat release. They are a challenging fire. I'll talk about, and I'll show you a video of some testing done with Group A plastics. Group B and C, not so much, but still they have to be dealt with separately from the more traditional commodity classes. Elastomers and rubber, again, some of those burn with some intensity and will drive our densities up substantially. And then into special products, which used to be separate standards, including rolled paper, which you don't see all that often. There are a few out there, but rubber tires are a little more common and very challenging, not just because of the material, but the geometry of the product itself. So rubber tires are very challenging to deal with. And then baled cotton, which you don't see much of, but we still have to address that configuration as well. So very briefly, let's look at the commodities. Class 1, for example, is a non-combustible product. It may be placed into combustible packaging, in this case in a cardboard container. May or may not have dividers inside that container, and typically are stored on wood pallets or maybe even as a solid pile. But again, a non-combustible product does not present a very significant fire hazard. And as you might imagine, the densities and protection criteria for a class 1 commodity are relatively low. And we can deal with this very easily in chapter 20, particularly in storage heights of 12 feet or less. So not very challenging. Class 2, again, can still be a non-combustible product, but now have more significant packaging that present a little more combustibility. And as you might expect, the densities and protection criteria for a class 2 commodity would be a little bit higher than class 1. These are addressed again in chapter 20 in section 20.4.2. Now, a class 3 commodity is where we start looking at products that are combustible. And again, the packaging can be in cardboard or wood containers. There may be a mixture of plastics involved. So there could be limited amounts of Group A or Group B plastics, and may or may not have pallets associated with them. But again, a product that that is combustible and is going to require a higher level of protection. So in this case, we're looking at plastic cups, for example. The Class 4 commodity is, again, a product that certainly is combustible. And again, this is where we will see more of a mix of Group A plastics, in particular, some Group B perhaps, and free-flowing materials, so that when the container is compromised, these products may spill into the aisles, which we have to consider again. And the method of storage could be with or without wood pallets, or they can be placed in racks, of course. Now, the subdivision for plastics, again, I've mentioned A, B, and C. Class A is of most concern. That's the one that burns more vigorously than the other two. You'll see Group B and C plastics are treated as a more or less common commodity. So they're not as significant a hazard. Now, when we talk about plastics, what's important, and you will see different protection criteria for Group A plastics, whether they're expanded or non-expanded, and expanded, of course, being something that has a lot of air inside it versus a solid piece of plastic. And we also look at these commodities as to whether they are stored in an exposed or inside a carton configuration. And the protection criteria will differ depending upon that storage method. And you can see the decision tree in figure 20.4.8, when we break down the plastics into various groups. Now you can see the difference between cartoned and exposed, or free flowing, and then expanded versus unexpanded. The protection criteria will be dictated by the configuration of this product and how it's stored. So this decision tree will send you to the appropriate section for that protection criteria. So that takes care of the commodities, but now how do we manage those? How do we store those? And just a little bit about how these the storage arrangements are handled. So what do we do if a warehouse has different adjacent commodities? And it's very simple. If a warehouse stored only one product that was one commodity in one storage method, but in real life, we know that doesn't happen. So in many cases, there will be higher hazard and lower hazard areas. So how do we treat those? Well, when we have a lower hazard area, we want to protect that from the higher hazard area and design to a lower density. So we're not over designing in specific portions of the warehouse. So in this case, we could segregate the two areas by a draft curtain. So the hot gases from the higher area don't travel into the lower hazard area and affect or open sprinklers there. So the options here, if you have a copy of NFPA 13 available, we treat adjacent hazards with different design methods in Chapter 19 in Section 19.2.2. And it generally basically says where areas are not physically separated by a draft curtain, barrier, or some kind of partition, as I'm illustrating in this slide, there's a draft curtain. We would extend the higher hazard area into the lower hazard area by 15 feet. So the higher density on the left-hand side of this slide would be extended into the lower density area on the right-hand side of that slide. So here's the illustration for that. Without the draft curtain now, I would take the higher density and calculate that into the lower hazard area to compensate for the different protection criteria between the two. And that's in Section 19.2.2, and it's repeated again in Section 20.10. So these sections further state that the requirements, previous requirements, do not apply where the areas are separated by, again, a draft curtain, or where there's an aisle of at least 2 feet of horizontal separation, or in a case where there's a different ceiling elevation, at least 2 feet different between the higher and lower area. So again, We're looking at how the hot gases will travel. So we separate either by a draft curtain, extending protection criteria, or looking at lower hazard or ceiling or roof elevation change. So if a warehouse has two different roof heights with the same commodity, what do we base our protection on? Well, we would base our protection on the storage height and the separation from that storage to the underside of the ceiling or roof deck. If the warehouse has two different roof heights with two different commodities, how do we deal with that? Well, again, we take the worst case. You look at the higher hazard commodity and the higher storage height, and whichever works out to be the worst case, that's what we design to. And very briefly, just an illustration of a draft curtain on the right-hand side. What about roof vents? Well, roof vents, if they open too quickly, will exhaust the gas and impact sprinkler operations. So we do have to consider those as well. I'm not going to get into a lot of detail on that, but be aware of that if roof vents are present. Okay. The other issue here is idle wood pallet storage. Now, just looking at this picture, you can see we have a combustible commodity with significant airspace in between them, and pallets are a significant hazard. So there is protection criteria in section 20.14 dealing with all three different sprinkler types, whether control mode or special application or ESFR, dealing with idle wood pallets. Now, I can say some insurance companies may not permit idle pallet storage inside a building and would require that these be removed from the building with significant separation from the building. That's how much of a hazard a pallet can present. But there is protection criteria in NFPA 13 for idle pallet storage. So even the pallets themselves are addressed by the standard. Several years ago, we started seeing a significant amount of high volume, low speed or HVLS fans installed for environmental reasons in warehouses in particular. And we found that there is an interaction between the operation of these fans and sprinkler operation. The NFPA Research Foundation and the Property Insurance Research Group were involved in studying the effects of HVLS fans on sprinkler operation. And there is some criteria in NFPA 13 as a result of that research in section 20.6.7 that basically states we'd like to see the fan centered between sprinklers, as illustrated in this photograph. Certainly clearance, vertical clearance from the sprinklers to the fan itself. Most importantly, at least in my opinion, is the fact that the fan has to be interlocked with the flow switch on the sprinkler system. So when the first sprinkler activates and the flow switch kicks in, we want that flow switch to also shut off the fan. Otherwise, as you probably already can tell, that this fan is going to move a significant amount of air, and it's going to push the hot air away from sprinklers that should be operating and might cause sprinklers to operate that are not going to contribute to suppression or control. So HVLS fans came into play several years ago, and protection criteria has been in NFPA 13 since about the 2013 edition. So be aware of that as well. You will see significant installations of HVLS in warehouses. Okay. We also have situations where there will be steel columns in close proximity to storage racks. There is a steel building column protection criteria in NFPA 13 dealing with this. So essentially sidewall sprinklers spraying that steel where required. So keep that in mind as well, that there could be requirements for making sure that that steel column stays relatively cool if any of these racks become involved. So steel column protection, kind of unusual. There is also a room design method involving storage. And again, this would be primarily low-piled, not high-piled storage, because we're still in Chapter 20. But very similar to the room design method in non-storage occupancies, we do have a room design option in Section 20.8 for storage occupancies. Many years ago, before the storage was actually brought into NFPA 13, there's kind of an interesting story. There was discussion of taking out hose racks or any hose rack requirement or allowance in warehouses. And during that committee meeting, I was really surprised to find that several major insurance companies that sat on the committee at that time were adamant about keeping hose racks involved, particularly in warehouse occupancies. Although I never saw any hard data, they all agreed that there are significantly lower dollar value losses associated with warehouses that have hose racks versus warehouses that do not have hose racks. So the hose rack apparently, at least from a loss perspective from the insurance industry, do make a significant impact. So they're here to stay. Are hose drops required in warehouses? Well, they're permitted. I think the insurance company is certainly going to require them. What is the purpose? Obviously, it's not just mop up initial attack. If you have trained staff in that warehouse, trained in the use of that hose rack, most likely, based on what I heard at that committee meeting years ago, you will see significantly lower dollar value loss involving fires in a warehouse. Something else that we did in this reorganization in Chapter 20 is all of the hose stream and water supply tables were consolidated and brought into Chapter 20. So everything you need to know about hose demand is in one place, should be much more convenient to use, and is listed in a single table in Table 20.12.2.6. And this includes not only hose demand, but certainly duration. And again, that duration will come into play if you have a fixed water supply. So I do have an example coming up very shortly. Matter of fact, probably in the next slide or close. Let me get over to this. Okay, here we go. So to determine the water supply for any sprinkler system, not just in storage, we look at the sprinkler system demand itself, plus any hose demand, plus the duration or times the duration that's specified in that table. And if you're taking your water supply from a water tank, this is a critical calculation. If you're taking a water supply from a city water supply, duration isn't all that important, but certainly from a fixed water supply it is. So there are some very significant durations listed in that table, as much as 2 to 3 hours in some cases. Okay, so let's talk about Chapter 21, and this is control mode density area sprinkler protection for storage. So once we decide to use this type of sprinkler, Chapter 21 is where we need to be. And without going through every line in this chapter, this is the general arrangement of the chapter and what you will see when you go to Chapter 21. So commodity class, or the type of material we're protecting, adjustments for sprinkler temperature rating, and I'll show you that in just a moment. But looking at storage arrangement. And again, if we start looking at situations requiring in-rack sprinklers, reference will be made to Chapter 25. The next consideration, storage height, roof or ceiling height, and then aisles, and the type of racks, if racks are involved, and whether in-rack sprinklers are required or not. So if they are required, again, we send you to Chapter 25. There are some restrictions on the use of these sprinklers. Again, minimum densities, Sprinkler K factors are required based upon the design density, so we make that decision for you. The higher the density may drive a K factor of 8 versus 5.6, for example. There could be some quick response allowances here as well. Sprinkler temperature requirements, I'll get to that in just a second and show you the differences there. And adjustments for not only storage height, but now for encapsulation. So if the commodity is encapsulated in plastic, we don't see as much wetting of adjacent combustibles, so that will affect and impact your design for the discharge density. So for non-rack storage, we'll stay in Chapter 21. The protection criteria, as you can see, is still in Chapter 21 in Section 2 and 3. But again, in rack, we'll send you to Chapter 25. But the density tables now, if you look at the graph on the left, those densities are based upon a storage height of 20 feet for ordinary temperature sprinklers. However, we've made the adjustment for you. The graph on the right is an illustration of the density requirements for still 20-foot high storage, but the utilization of high temperature sprinklers. So there is an advantage to using high temperature sprinklers, just as there is in Chapter 19 for more conventional or non-storage sprinkler systems. And the thought process simply is that with ordinary temperature sprinklers, there is a potential for more skip, what we call skip, where enough heat is generated that sprinklers are going to operate outside of the immediate operating area, whereas with high temperature sprinklers, you don't see that phenomenon. So we don't need as much water to combat that type of fire. So there is a difference between the two temperature ratings. And then with this figure in Chapter 21, all of those densities that I'd mentioned are based on a storage height of 20 feet. From there, we adjust. When we use this table, if as you can see, if the storage height is lower than 20 feet, we have an advantage. We use something less than 100% of the density specified in that table. But as you can see, as the storage height increases, we start using a higher percentage of that discharge density. And this is an adjustment to the density itself, not the area of operation. This is an adjustment to the density. So again, in the back of Chapter 21, when we start dealing with higher levels of storage, that's where you find that information. I'm not going to go into a lot of detail there. We don't have that kind of time today. But this is just, excuse me, a general overview of how this chapter is arranged. And the other two chapters are very, very similar. Towards the end of the chapter, now we start looking at other types of storage or other commodities rather, such as rubber tires. So a specific table for rubber tire protection, same thing for roll paper. Then we get into slatted shelves and retail stores, baled cotton, and specifics that you don't see in every type of warehouse, but that's the general arrangement of the chapter. So previously, where we dealt with a separate chapter for example, rolled paper or rubber tires, for example, it's all in this chapter now based upon the type of sprinkler that we're using. Chapter 22 for special application sprinklers is very similar in organization. And as you can see, we start looking at commodity class and then storage type, storage height, sprinkler K factor, and so on. So it's very similar to the previous chapter, except it's a different design option for higher flow sprinklers. These are previously the large drop, or now referred to as special application. So the same approach in the chapter for CMSA versus CMDA sprinklers. And again, Chapter 23 is dedicated to ESFR sprinklers. Similar approach here as well, except much higher flows, and probably I'm going to say ESFR is probably the most commonly used sprinkler for storage applications versus special application or conventional sprinklers. So, and this is where we're seeing a lot of research and development continues. The ESFR sprinklers have only been available in the last 20 years or so, 25 years maybe now, but it's still, this technology is still evolving, and these are probably the best tool for dealing with storage problems. So the chapter, again, is organized in a similar fashion to the control mode type sprinklers. So everything you need to know is by chapter again. This is an example of rack storage protection of Group A plastic. And this is the result of this particular fire test. I do have a video of this test on the next slide. So let's take a look at this video. This was a test conducted at Underwriters Laboratories, and it's a Group A plastic. And as fire tests go, you will see the first few seconds after ignition, but very shortly it becomes quite obscured. So this was the Fire Protection Research Foundation. This is one of a series of full-scale tests conducted at UL. And the intent of this was, again, a Group A plastic. And it's documented in a report called The Protection of Rack Stored Exposed Expanded Group A Plastics with ESFR Sprinklers and Vertical Barriers, which is available from our website for download. So if you want to take a look at that report and the test results, those are available. Details on this test are available in the NFPA 13 Annex. So you can get a breakdown of what the testing included and what the results were. And you can see in the video, we now have ignition. And this particular video is from test 3. And let's see, this is going to think about in terms of how quickly this fire travels to the top tier of storage. And you can see how rapidly a Group A expanded commodity will cause fire spread. Now the first sprinkler is activated, and that's going to push the fire through the rack towards the aisle on the left just a bit. And you can see that as it progresses, things become much more obscured. And it very shortly will switch to the IR camera, because that's the only way you can actually observe the fire test. So we're just about 100% obscured at this point. But that took just a few seconds from ignition. So you can see it was very rapid. Imagine a warehouse full of this commodity without adequate protection. That would be a very bad situation. Now the IR camera, you can see where the fire is in that rack, and it's really not spreading that far. So this, if we could see a time temperature curve, we could probably assume at this point that suppression has been achieved. Certainly have control, but this is a good illustration that suppression has been achieved. And we'll let the video go just for a few more seconds. And we'll talk about the other storage chapters, NFPA 13. There we go. Okay, just to give you an example of just how severe these fires can be. So the rest of the ESFR chapter is very similar, as I mentioned, to the special application and control mode, where we look at other hazards such as rubber tiles, rolled paper. But in this case, high bay record storage, that was a separate research project. So a little different from the special application, but the rest of the chapter is laid out basically the same. So there is some consistency there. Now in chapter 24, this is alternative storage protection. This is primarily, this chapter, you probably won't use this too much. This is primarily written for sprinkler manufacturers and maybe others who are developing protection criteria for storage occupancies other than what is already included in NFPA 13. So this chapter really establishes test protocols and some basis for criteria development. So you'll see that manufacturers will use this. You and I do not use this for designing systems for warehouses. Now, finally, and this was sort of a change during the revision process. Initially, the committee was going to take rack storage and break it into the various sprinkler chapters, but it was decided during the essentially the first and second draft meeting to keep the in-rack storage protection criteria intact in a new chapter 25. So everything you need to know, once you know that you need in-rack sprinklers, everything you need to know from that point on is in chapter 25. And this is the general organization of how chapter 25 is put together. As I always say in talking about NFPA codes and standards, don't try to memorize this. I have a feeling that this chapter will change significantly once again as we enter cycle, and I'll talk more about the upcoming revision cycle. But this is what it looks like right now, and again, I suspect that this is going to be further enhanced as we go forward. So all of the protection criteria for everything you need to know for in-rack sprinklers, including the different types of overhead sprinklers, the density area special app, and certainly ESFR sprinklers are all contained in chapter 25. Okay, that's basically the new organization of NFPA 13 in respect to how we deal with storage. And again, I would like to ask for a polling question, and that is, how do you feel that the new approach to dealing with storage will improve how you design in-rack systems or warehouse systems? Do you think it's a better tool? So think about this approach. Do you think it's better this way, or do you think it's better analyzing the storage? And I'll give you a few seconds to think about that. Okay. And I think the poll is closed. There we go.
All right. And Dave, yep, we'll close the poll. And we're having 79% of the attendees polling yes, and 21 then saying that their new approach is not as helpful. So.
Okay. So a slightly different response level to this. Okay. Good to know. And I'm not certain that will change going forward. Can everyone see my screen again?
Yes, back on.
Okay, good. All right. I'm not sure that will change going forward, but that's good feedback to know. Again, it wasn't designed for us as engineers necessarily. It was really intended to help the plan reviewer or the casual user of the standard. But what I am hearing is for some of the members of the committee that did not embrace this approach, myself included, we are getting used to it, I guess, and starting to acclimate more towards, yes, it does make sense for that reason. So it helps the casual user. we'll see as that goes forward. But obviously, the numbers were very different than how you felt about my roadmap. So I felt good about the roadmap. All right. Some ongoing research. There is an NFPA research program that is not quite wrapped up yet, but a few more tests need to be conducted. We've completed phase 1, and this is dealing with protection of storage under slope ceilings. Now, if you've used NFPA 13 in the past, you know that a slope in excess of 2 and 12 becomes very problematic, and we don't have protection criteria for that. So we're looking at that very closely. This project is in 4 phases. Phase 1 has been completed, and that was sprinkler characterization testing. I can't tell you too much about that yet because we haven't finalized it, or the vendor that's doing the testing hasn't finalized the report. So phase 2 is full-scale test plan was developed, and we are implementing that plan as we speak. I witnessed this test just a few weeks ago. So phase 3 is the testing phase. This was a roof slope of exactly 2 and 12, and involved 12-inch purlins, 24-inch girders, and this system was arranged for the use of K17 sprinklers at 35 psi. And I'm very pleased to report that this test was a success. Unfortunately, I was unable to film or record any more of this test, so it's just a few pictures prior to the ignition. So you see a double row rack involved in that test with cardboard cartons containing plastic cups, which is pretty much a standard fuel package for testing, and of course a single row rack on the left of that array. And I'm very pleased that this test went well and worked, because this is existing criteria in NFPA 13, so it's good to know that this works very well. During this test, 6 sprinklers activated and achieved suppression. So that was really exciting to see. And once, as I mentioned before, whenever you look at fire testing, after a few seconds, everything's obscured and it's difficult to see the actual fire. But switching to an infrared camera and seeing a graphical display of the time temperature curve, this was a classic time temperature curve where you saw the peak, and once the first couple sprinklers activated, that temperature went right back down. So it was almost a textbook type of test. So it reaffirms this particular test criteria, which made me feel pretty good. Although I'm hoping, and I know that subsequent testing has changed the configuration at the ceiling. And the last test I haven't seen, I didn't witness this, but a colleague of mine did attend the last test. And some of the criteria was altered, and the test was not so successful. So we're still in that process of pushing the limits of the protection criteria to see exactly what the impact will be. So phase 4 will be a wrap up of this testing plan, and we're hoping to have a final report in June of this year, which is the perfect time for NFPA 13 to begin its next revision cycle. So we are accepting public input as we speak. As a matter of fact, the closing date for that is June 10th. So if you see something in the 2019 edition that you're not happy with, or you'd like to see changed or modified in some way, now is the time to let us know. So the good news about this test program is we'll have some data for the committee to review going into the next revision cycle. So I'm hoping that if we reveal that we can tolerate different slopes or different ceiling configurations, we'll be able to make those modifications for the next edition of NFPA 13. So with that, concludes my presentation. And at this point, I would like to entertain your questions. I do want to point out that we do offer support. So don't be a stranger. Get on our webpage, nfpa.org. There's a multitude of information about what's happening with our codes and standards. And for NFPA members, again, don't be a stranger. You can ask technical questions. There's our 800 number, and whoever is on phone duty for the day will respond to your technical questions. So a big part of what I do at NFPA is not just revise standards, but I spend a good deal of time working with our members and navigating the codes and answering technical questions. You can also do this online through our website. So take advantage of that membership benefit. It's really important to do that. That's I think a good service, and we take that very seriously. And I have to give you the final slide for training and certification. We do offer a multitude of training. And in the NFPA 13 seminar, it lasts a lot longer, and we dive into a lot more detail on storage. I wish we could spend more time talking about storage today, but we're limited on time, and online it's difficult to do unless we're in a different venue. So we could spend a lot more time on storage. It's a very complex topic, as you could see, and it can be very challenging. So with that, any questions, I'll be here to help you with. And Lou?
Yep, thanks, Dave. We do have some time to take questions, so let's go ahead and get started. So the first question we have, in regards to your roadmap, someone was just asking what the asterisk means on the roadmap, if you could just provide some insight there.
Certainly. The asterisk, like in any NFPA code and standard, the asterisk indicates that there's annex material associated with that section. So we simply carried the annex, the asterisk over, rather than replicating every section that has annex material. So if the main section moved to a different chapter, a different section number, the annex followed. That's all that means.
Great, thanks. The next question, I'm assuming your answer is going to be it depends a little bit, but the question was, when the roof heights differ, is it better to keep the higher challenge commodity under the lower roof deck?
Well, yeah, you're right, Lou. The best answer in fire protection is it always depends. There's so many variables here, but absolutely, if you have a higher challenge commodity, it's always best to limit the storage height because protection criteria will decrease according to a lower storage height. So absolutely, keep it as low as possible. And the cutoff historically has been 12 feet. If you're under 12 feet, you can work with a protection criteria in Chapter 20, which is much less than what you will see in Chapters 21 through 23. As a matter of fact, the protection criteria in Chapter 20 for storage less than 12 feet can send you back to the more traditional area density curves and may say protect this as an ordinary Group 2 or an extra Group 1. The next significant cutoff, particularly for Group A plastics, is under 5 feet. So the lower the better as far as some of the higher hazard commodities. So if you have that option, by all means, take advantage of that as well.
Great. The next question we have is in regards to section 20.8 for room design method. Is this intended for storage areas in non-storage occupancies?
This can be used, I believe, in any storage configuration. I'd have to double check that, but I'm certain that the room design for storage can be used in any storage configuration. I'm just going to check the standard very quickly. And really all the standard says is the water supply requirements for sprinklers shall be based upon the room that creates the greatest demand. It's not limiting us to storage occupancies only. It's only for storage rooms. So if you're thinking about a storage room in a different occupancy, you should be able to use that protection criteria.
Great. The next question we have is, has the values for water supply and durations changed significantly from the 2016 version?
They have not changed significantly. What we did do was just gather them all and put them into one table, so it's a one-stop shopping, so to speak. I don't think we're going to see significant changes in quantity or duration for water supplies.
Great. A clarification on the hose drops. Are hose connections required by NFPA 13, or is it up to the AHJ and insurance company?
Hose connections are not required. They are simply permitted, and we provide guidance on how they should be installed and controlled.
Great. Next question is there still the section that counts K12 and larger orifice sprinklers as high temperature even at 165 degrees Fahrenheit rating?
Offhand, I don't know the answer to that question. I'd have to do some research for that. So perhaps I could email an answer to Lou after this presentation.
Great, absolutely. The next question we have is manufacturers are moving towards larger K-factor sprinklers. Specifically, one manufacturer has a sprinkler with a K-factor of 33.6. Do you have any comments just on these new larger orifice sprinklers and how the committee and the standard will address those?
I think as manufacturers produce more sprinklers, and looking at it from their perspective, manufacturers are obviously looking for market opportunity, and if they can find a better way for a protection scheme, they will design a product to address that. So the committee is cognizant of that. All the major manufacturers are represented on the committee. So as new products are continually developed, they will be introducing protection criteria to the committee. Keep in mind that in Chapter 1, there is a section that deals with new technology, and that was added to the standard because at times new technology is outpacing. It's just coming out faster than we can produce a revised standard. So there's ways to use the latest and greatest sprinkler without waiting for NFPA 13 to be revised. The other issue is it's a matter of listing as well. You want to make sure that the sprinkler obviously is listed, which means it's been tested and evaluated. So the committee is very aware of new technology because the manufacturers just won't let us ignore it. So I think the newer K factors will become recognized in the next edition as soon as we have good solid test criteria that indicates that the tests are repeatable, the results are repeatable, and the sprinkler does the job that they're claiming it to do.
Great. The next question we have is, has NFPA considered conducting fire tests to develop protection strategies for open top containers located in rack storage?
I'm not aware of any such research project at this point. Just keep in mind that research funding is limited, and conducting active fire testing is very expensive. So we're trying to maximize the investment. So we're looking at some of the major problems we're having, and that was slope sealing was decided. That was one. The next one we're looking at, and I wanted to mention anyway, is parking garages. There have been some significant fires involving parking garages, and I'm thinking that the classification, the hazard classification for parking garages, which has historically been ordinary Group 1, is probably going to jump to something like extra Group 1 or 2, I'm even hearing. But there is an ongoing research project looking at that right now. We're not at the point where we're going to do any active fire testing, but we are doing some research in that regard. I haven't heard anything about open top containers, but that is another issue where we could probably come up with some better criteria given the testing. But again, we could spend millions of dollars on testing. We just don't have that much, so we have to pick and choose our biggest problems.
Great, and this kind of leads into the next question we have here is how much do the committee and the standard utilize computer simulation, CFD, especially using FDS? Is it feasible to use these computer simulations rather than full-scale tests?
That's a good question, and it's probably a better question for someone who's actively involved in the testing. There's almost no reference to that in the standard right now. As far as simulations go, I haven't really heard a lot about that being utilized, but probably not the best resource for testing. That's a whole separate issue entirely. So unfortunately, I don't know a lot about utilizing simulations or how testing is conducted. I'm just more interested in the results and how it impacts the standard. So unfortunately, I don't have a very good answer for you on that one.
And Dave, if you don't mind, I actually could probably address that a little more. I think currently with the state of modeling, I think and the testing labs and manufacturers use that to guide the full-scale testing, but then still look for the full-scale testing for verification of their results. I believe that's how it's utilized at this time, but it would depend on the scenario a little more.
Good answer. I just learned something.
Yeah, that's the only thing I can contribute to this conversation right now. But we are at the top of the hour, and we do have quite a few more questions. So, Dave, thank you for the wonderful presentation. If you mind, I'll go ahead and send these questions over to you. And when you get time answering them, you can just respond to the individuals. Other than that, I think I thank everyone, Dave and everyone for attending.
Thank you, Lou, and please do send those questions to me, and I will get to work on them right away. And I do want to thank everyone for coming in for the good questions. So hope everybody has a good day, and thanks once again. Thanks for having me.
Great. Thanks, everybody.